Right now, at this exact moment, you are burning fossil fuels. It's not because you drove somewhere, and it's not because you left the light on. You are burning them because you pressed play on this podcast. Today, in honor of Earth Day, I am talking about the tech industry and artificial intelligence. Hi, I'm Gabrielle Burchak, and this is Math, Science, History. Somewhere, probably in Virginia or Iowa or on the outskirts of Dublin, a building the size of several city blocks is constantly humming. This building is filled with servers, stacked floor to ceiling, each one drawing electricity around the clock, every hour of every day, whether anyone is listening or not. That building exists in part to serve you this audio file. We talk a lot about fossil fuels on Earth Day. We talk about cars, factories, plastic straws, and fast fashion. But we almost never talk about this one thing, the invisible infrastructure that powers our digital lives, the internet, the cloud, and now the booming world of artificial intelligence and what it is costing the planet. In the United States alone, data centers consumed about 176 terawatt hours of electricity in 2023. That's 4.4% of the entire country's power use. Today, we're going to talk about that. And I think it's going to make you look at your phone a little bit differently. Every year on April 22nd, which is Earth Day, we zoom out. We look at the big picture, the glaciers, the coral reefs, the carbon in the atmosphere. And every year we focus on the usual suspects: transportation, energy, agriculture. These are real, important, and urgent. But there's a sector that has largely escaped scrutiny. A sector that has successfully marketed itself as clean, modern, and progressive. A sector whose logos are bright and friendly, whose founders talk about saving the world, and whose products, we are told, are making life better. So we are told. And here's the central question I want to explore today. When we moved our lives online, our entertainment, our communication, our work, our memories, did we make an environmental trade? And if we did, was it a good one? And now that artificial intelligence is supercharging digital consumption at a scale we've never seen before, are we even paying attention? So let's start with what we already know, or should know, about the internet's hidden footprint. According to World Bank ICT emissions report, the global internet is responsible for somewhere between 2 and 4% of worldwide carbon dioxide emissions. That puts it roughly on par with the entire aviation industry. So let's let that land for a second, pun intended. We spent a decade debating whether people should feel guilty about flying. We wrote think pieces. We invented the concept of flight shame. Meanwhile, the internet, which most people use every single day for hours, gets almost no comparable scrutiny. Why is that? Because digital feels clean. You can't see it. There's no exhaust pipe and there's no smoke. When you tap a screen and things happen, it all feels weightless. But it's not weightless. Let's break down the anatomy of this problem. The internet's carbon footprint comes from three main places: data centers, transmission networks, and the devices we use. Data centers are the big one. Globally, there are tens of thousands of physical buildings that store and process the world's information. The largest ones, which are owned by Amazon, Google, Microsoft, and Meta, can consume as much electricity as a small city. According to the Department of Energy's Lawrence Berkeley National Laboratory, U.S. data centers consumed 176 terawatt hours of electricity in 2023 alone. The average home in the United States consumes approximately 10.26 megawatts per year. So, if we do the math and we divide 176 million megawatts by 10.26 megawatts, we get approximately 17 million homes. 17 million homes. This means that U.S. data centers used enough energy to power 17 million homes for an entire year. So, what are they powering? A lot of streaming video on Netflix, YouTube, TikTok, Disney Plus, etc., etc. So, these platforms are streaming accounts for a majority of global internet traffic. So every time you put on a show before bed, a data center somewhere is spinning up servers to send that content to you. And then there's the stuff we think of as trivial. Every email you send has a carbon cost, from a few grams for a plain text note to over 20 grams of carbon for one with an attachment. And people send roughly 300 billion emails per day. Global email traffic accounts for as much as 150 million tons of CO2 per year, roughly the same as putting 7 million extra cars on the road. Even a single email with a large attachment can carry a carbon cost up to 26 grams of CO2. The math is not kind. A single Google search uses about 0.3 watt-hours of energy, and that sounds tiny, until you multiply it by the billions of searches performed every single day. Add to it, we now have the unwanted AI feature that automatically uses AI when we use Google, which is consuming even more watt-hours of energy. Then there's the hardware itself. The devices we use, our phones, our laptops, our tablets, require enormous amounts of energy and rare earth minerals to manufacture. The production of a single smartphone generates anywhere from 50 to 95 kilograms of CO2 before you even turn it on. The global e-waste problem is already staggering, with over 50 million tons of electronic waste generated annually. That's less than 20% of which is formally recycled. This is the internet we already have. Now, let's talk about what's coming. If the internet's environmental footprint was something we should have been talking about for years, artificial intelligence is the thing we need to be talking about right now. AI is not just another app. It is a fundamentally different kind of computing, one that requires vastly more energy, vastly more water, and vastly more physical infrastructure than anything that came before it. So, let's start with training. When an AI company builds a large language model, the kind that powers tools like ChatGPT, Gemini, or Claude, they run an enormously intensive computational process. Researchers at the University of Massachusetts Amherst found that training a single large AI model can emit more than 626,000 pounds of carbon dioxide equivalent, nearly 5 times the lifetime emissions of the average American car, including its manufacturer. Additionally, in 2020, when training ChatGPT-3 specifically, the model that underlies ChatGPT, it was estimated to have consumed 1,287 megawatt hours of electricity, generating roughly 552 metric tons of CO2. That's comparable to the annual emissions of more than 100 gasoline-powered cars. But training is a one-time cost. What is more alarming is inference, what happens every time we use an AI tool. According to the International Energy Agency, a single ChatGPT query requires about 2.9 watt-hours of electricity, and that is roughly 10 times the energy of a standard Google search. And I'm not talking about today's Google searches, which automatically use AI. I'm talking about the old school searches that just provided links, kind of like Ecosia. Ecosia only provides the links. So it uses AI only when you select the AI search function. Otherwise, you go old school. I love it. However, let's play devil's advocate and consider that some research suggests efficiency gains have narrowed for this gap for newer models. However, the directional reality is this: AI uses far more computation than search, and this is not disputed. In a projection report, Goldman Sachs Research noted that global power demand from data centers will increase by as much as 165% by 2030 compared to 2023 levels. And this is driven primarily by the AI boom. In the United States, data centers could consume up to 12% of all electricity by 2028, according to the Department of Energy. And it gets worse. AI doesn't just need electricity, it needs water, enormous quantities of it for cooling. Microsoft's own environmental report disclosed that its global water consumption jumped 34% from 2021 to 2022, rising to nearly 1.7 billion gallons, a surge that researchers directly attributed to its AI build-out. We'll be right back after a quick word from my advertisers. And here is what I find most troubling about all of this. The explosion in AI infrastructure is happening right now. Even though most of the world is committed to reducing carbon emissions, we are adding enormous new loads to power grids that are still, in many places, heavily dependent on fossil fuels. And we are doing it at a breakneck speed, driven by competitive pressure and investor expectations. We got to think about the oligarchs, with almost no public conversation about the environmental cost. Take a deep breath, Gab. So, where does the power actually come from? Well, this is where things get particularly frustrating because the tech industry has been so good at telling a clean story about its energy use. Google claims to be carbon neutral. Microsoft has pledged to be carbon negative by 2030. Amazon says its operations run on 100% renewable energy. These are the headlines. The reality is considerably more complicated. Most of these claims rely heavily on the purchase of something called renewable energy certificates, or RECs. When a tech company buys an REC, they are essentially paying for the right to claim that a unit of renewable energy was produced somewhere on the grid, not necessarily the energy that actually powered their data center. Critics argue that this is a counting sleight of hand, not a genuine decarbonization. And here's the ground truth. A 2024 study of over 2,100 U.S. data centers found that 56% of the electricity powering them came from fossil fuels, with 16% coming from coal specifically. The same analysis found that data centers' carbon intensity was 48% higher than the U.S. national average. Meanwhile, the scale of new data center construction is outpacing the build-out of renewable energy. In some regions, utilities have had to delay retirement of fossil fuel plants, including coal plants, specifically to meet the new power demands of AI infrastructure. So we're continuing the use of all of these fossil fuel plants and expending more energy. Yes, some companies are making genuine investments, building dedicated solar and wind farms, signing long-term power plant purchase agreements, investing in battery storage. That's real, and it matters. But the pace of investment in clean energy is not matching the pace of demand growth. We are building the AI economy first and figuring out how to power it later. That is a huge problem. And it sounds very similar to the Industrial Revolution. And I know there are those out there that say, can't AI save the planet? And yeah, possibly, because every time someone raises concerns about AI's environmental impact, the response comes quickly. AI can help solve climate change. But this is not a dishonest argument. It's true. Yes, AI is being used in some remarkable ways for environmental good. AI systems are being used to improve weather forecasting and climate modeling. That's good. Google DeepMind built an AI that cut the energy used for cooling at Google's data centers by 40%, which translated to a 15% reduction in overall power usage at the test site. AI is being deployed to analyze satellite imagery to detect deforestation in real time. It's being used to optimize energy grids, route logistics more efficiently, and accelerate material science research for cleaner batteries and solar panels. These applications are real and they matter. I am not dismissing them. But here is my challenge to the AI will save us narrative. The applications I just described represent a fraction of what AI is actually being used for. The overwhelming majority of AI compute cycles are going towards chatbots, image generation, marketing copy, and recommendation algorithms. The bulk of AI's energy consumption is not being spent on climate modeling. It's being spent on helping someone write a slightly better email or generating a photorealistic video of a bunny entering a room with a bouquet of flowers in its paws. It's just goofy. We don't need this. Columbia University's Earth Institute notes that the tension is real. Basically, they're saying it may be worth using enormous amounts of power to build a new climate model, providing us with the data we need to act to reduce emissions. The question isn't whether AI can help the planet, though. The question is whether the AI we are actually building and deploying at the scale with this energy mix at this speed will be a net positive or a net negative for the environment. And that question is wide open. Nobody can answer it honestly yet. Or if they can, they're just not doing it because the industry is moving too fast and the data is way too opaque. It's like this. Imagine sitting in an auto-driving car. You can't drive it, it's driving for you. And you're hurtling uncontrollably toward a brick wall. You're not at the wheel, yet you can see the impending crash ahead. Every second closer is a moment lost to intervene. This is the reality of how AI-driven technologies are accelerating environmental destruction. We look on as energy consumption skyrockets, raw materials are mined at unsustainable rates, and e-waste piles up, all while the system relentlessly pushes forward, indifferent to the damage. Like passengers trapped in that speeding vehicle, we have to find a way to hit the brakes before the collision with our planet's limits become irreversible. So, what do we do about it? I'm going to be totally honest with you, and it's not an opinion. It's about the damn oligarchs. There is a trap that a lot of environmental commentary falls into as pushed forward by the propaganda of the oligarchs, and that is pretending that our personal behavior change is the primary solution. It's not. Yeah, we can think about our digital habits. We can clear out our cloud storage. We can choose to download videos instead of streaming them repeatedly. We can be more intentional about which AI tools we use and how often. None of that is meaningless. It is not. But in reality, the scale of the problem is not at the individual level. The decisions that matter most are being made in boardrooms and legislatures, not on our phones. What would actually move the needle? Well, mandatory energy disclosure for data centers. Right now, most companies are not required to report how much energy their AI systems consume. Seriously. The U.S. Senate introduced the Clean Cloud Act of 2025 specifically to address this gap, giving the Environmental Protection Agency and the Energy Information Administration authority to collect data on data center energy consumption. We need clean energy mandates tied to data center permits. If you want to build a 100-megawatt facility, you should be required to demonstrate that you have contracted for equivalent clean power, not paper credits, but actual clean electrons. We need the tech industry to stop hiding behind the carbon accounting tricks and start competing on genuine sustainability. Right now, the competitive pressure in AI is entirely about performance and speed and appeasing the damn oligarchs. There is almost no market pressure for environmental responsibility. That could change if investors and the public demanded it. And finally, we need to ask harder questions as a culture about what AI is for. Every technology embeds values. The values currently embedded in AI development are speed, scale, and shareholder return. They are not sustainability, efficiency, or climate responsibility. That is a choice, and it can be a different choice. We really need to reflect on our past mistakes. It is crucial to remember the profound and irreversible damage wrought by the Industrial Revolution. This era didn't just threaten a few species. It fundamentally altered the planet's climate by flooding the atmosphere with greenhouse gases, reshaped vast landscapes through deforestation and urban expansion, and polluted air, water, and soil with toxic waste. These changes disrupted ecosystems and triggered biodiversity loss on a scale that still undermines nature's resilience today. Now, as we unleash AI-driven technologies with soaring energy demands and resource extraction, we risk repeating this history, accelerating environmental destruction and locking in damage that future generations will inherit without hope of reversal. The lessons of the past remind us that unchecked progress can come at a devastating cost, and the time to act responsibly is now. Earth Day was founded in 1970 because people looked at smog-choked cities and rivers catching fire and said, "This is wrong. We have to name it." The internet doesn't produce a visible smog. AI doesn't set rivers on fire. But the energy that powers them in much of the world right now comes from the same fossil fuels we've been trying to walk away from for 50 years. The invisibility of digital pollution is not a coincidence. It is, at least in part, a product of very deliberate branding. Tech companies have spent billions of dollars cultivating an image of cleanness, modernity, and environmental virtue. That image is not entirely false, but it is incomplete. And on Earth Day, incomplete is not good enough. I started today by telling you that pressing play on this podcast was burning fossil fuels. I stand by that. But I also want to be clear. I'm not asking you to feel guilty. Guilt is a dead end. I'm asking you to be awake, to be aware. I'm asking you to hold many things at once, and it's possible. We hold the genuine wonder of what digital technology can do, and we look at the genuine cost of how we are building it, and look at how we can demand transparency from the companies whose products you use, and to support policies that put real accountability behind the clean energy promises. So the next time someone tells you that AI is going to save the planet, ask them, which AI? Powered by what? Built how? Accountable to whom? These aren't hostile questions. They are questions that truly matter. Happy Earth Day. And until next time, my friends, carpe diem. Thank you for listening to Math Science History. If you want the next episode as soon as it drops, just tap follow in your podcast app. Math Science History is brought to you by caffeine. Delicious, delightful, life-supporting caffeine. If you'd like to support the show, you can find the coffee cup link in our show notes or at mathsciencehistory.com. Just click on that coffee cup. Your donations don't really go to coffee, but they really do help cover production costs. The MSH theme is public domain from the late, great music composer and professor, Dr. Lloyd Rogers. All other music is public domain from Pixabay. Until next time, carpe diem.